Today we'll start with section 7.4, which is all about calculating equilibrium constant. We're not going to learn how to calculate it like exactly, but we will introduce you about the values of Kc's and Kp's and what they can tell us more about the type of reaction. But you have to keep in mind, if you want to calculate the value of Kc or Kp, you need, for example, like for the Kc, you need to calculate the concentration of products and reactants, but at equilibrium. Okay, so the concentrations that are represented in products and reactants are for this species, but at equilibrium. On the other hand, if you want to calculate the Kp value, you need to calculate the partial pressure. For example, if we're still in the same reaction, we need to calculate the partial pressures for products and then divide them over the partial pressure of reactants, as we can see. And just make sure that all of these guys here are gaseous. All right. And keep in mind these partial pressures for sure at equilibrium. They're supposed to be at equilibrium. One more thing to be discussed with you, that the value of Kc or Kp both depend on the temperature. In other words, if you have done this experiment at different temperatures, for example, if you do, let's say, 3 experiments at 25 degrees Celsius, 40 degrees Celsius, and 100 degrees Celsius, you will have different values of Ks, regardless they are Kps or Kcs. But if you do the same, let's say, 3 experiments with different concentrations or different pressures, but the temperature is fixed, then the value of K for all of these will be equal. For this question together, the question says you are given a chemical reaction at equilibrium, and the question is giving me all of these concentration, but sure at equilibrium. Now the question is asking me to write the expression of the Kc. C is equal to the products. You have x, y to the power 2 because it's multiplied by coefficient 2, you can see, and then you divide it over by 2 to the power 3 and then multiply it by the concentration of x2. Okay, so I can say what's the concentration of xy? It's 0.09, so the answer is going to be 0.09 to the power 2 over the concentration of y2, 0.53. Okay, and it's raised to the power 3, and then you multiply it by the value of x2, which is 0.37, and then the answer is equal to 0.147. Let's start with section 7.5. We're going to say, like, if you were given the value of K, for example, Kc or Kp, what does this value tell? How can I get use of this value? There's a beautiful note that says, if the value of Kc or Kp, or generally K, is greater than 1, the products are favored. So why? If you look at the expression of Kc above right here, you can notice that it's the products over reactants. So if the value is greater than 1, then it tells you that you have more products than reactants. On the other hand, if the value of Kc is less than 1, okay, it tells you, since we have a products over reactants, you have so many reactants, and that's why the K value in overall has a low value. And at that point, we can say that the reactants are more favored. There is another piece of information. K is greater than 1000, which is a huge value. Then the reaction goes to completion, and it's almost in one direction. But if the value of K is less than 0.0001, then the forward reaction essentially doesn't take place, or almost it remains in the reactant side. So we have so many things that we can conclude about the values of K. What happens if the K is equal to 1? It means that the products and reactants are favored equally. So at that point, the K is equal to 1. Now let's have a question. Keep in mind this type of AP questions like to count the number of particles. So if you were given such a number of particles like this, just remember to count them. Okay? Now, the question is asking me to calculate the value of Kp. It doesn't matter whether it's Kp or Kc. So you have to say it's equal to, since you have the reaction in here, I have to say it's the partial pressure of AB over the partial pressure of B times the partial pressure of A. And just keep in mind, all of these guys are in the gaseous form. Since you're dealing with Kp, it's a gas and it should be, Now we have to say how many particles of AB we have. Okay, this is the AP. Then how many particles of AP? I can see that I have only one particle of AP. And that's why I have to say, okay, it equals to 1. And then you divide it over. How many particles of B and A? Let's count them. Let's count the B. 1, 2, 3, and 4. So we have 4 particles of B. And then you multiply them by the number of particles of A. How many particles of A we have? We have 1, 2, 3, and 4. Then you have to say you have 4 particles of A. Then the answer is equal to 1 over 16. 1 over 16, for sure, it's less than 1. Okay, and that's why, let's see. The question says, what can be concluded about the value of Kp? For sure, it's going to be less than 1 because you can see the denominator is greater than the numerator. That's why it's less than 1. So your answer is going to be C. Okay, let's take another question. The question says, which of the following equilibrium favors the products to the greatest extent? Okay, the products, it means it should be greater than 1. So I have to look which of these values has the greatest value that is greater than 1 for sure. So here you have negative powers, which means they're for sure less than 0. So I can cancel them out, the B and C. Now we have two possible answers. We have A or D. So which of these values is bigger? You have 5.5, and here it's 1.6. And for sure, in terms of math, A is the greater, and that's why the answer is